Now, in this video, we are going to work on problems related to maximum and minimum now, okay? Okay, so the example is I would like to find the critical numbers of the functions, then say if the numbers are stationary or singular, okay? So then let us start with our first example then, okay? Okay, so in order to, again, find the critical numbers, remember what we need to do is we need to find f prime of c equal to 0 or f prime of c does not exist, right? Okay. So that means we need to take the derivative. So f prime of x equal to 3x squared plus 12x minus 15. Okay. Then maybe we could factor the 3. Then we factor this out. So I have x plus 5, x minus 1 then, okay? Okay, so again, the 5 times -1 give me -5, and 5 minus 1 is 4, okay? So then I would like to set f prime of x equal to 0. I will have x plus 5 equal to 0 or x minus 1 equal to 0. Pause. I will have x equal to -5 or x equal to 1. And now, we will have the stationary number x equal to -5 and x equal to 1. Okay. Of course, in this case, we have no singular then. Okay. And my critical numbers x equal to -5 and x equal to 1. Okay. Same as the stationary numbers then. Okay. Okay, so now it's your turn now, okay? So work on the next example then. Then to be, if f of x equal to x plus psi of x, then its derivative will be 1 plus cosine of x. Okay. Then now I would like to set f prime of x equal to 1 plus cosine of x equal to 0. So I have cosine of x equal to -1. Okay. Okay, so then the easy way to work out this problem, work out the solution is, why don't we sketch the cosine functions? Okay. Then we find out that the output equal to -1. Then you have the intersections, this one, and so on and so forth, right? And of course, to this one here, we know that this number right here is pi. This will be the 2 pi, and then this one will be the 3 pi, and then this is the 4 pi, okay? So meaning in this case, the solution that I have, okay, for x is pi, 3 pi, probably be 5 pi, and so on and so forth, okay? Now, you know that we don't want to write the solution this way. We could actually write it like using, again, you know that the gap from here to here is 2 pi, right? And then from here to here is actually 4 pi, okay? So we could actually write as pi plus 2k pi. And then what is k? K is an integer then, okay? So remember, we prefer, okay, this answer. Yeah. And now, again, to this one, we will have stationary. Numbers, and of course, critical numbers, they are the same in this case. Okay, they are x equal to pi plus 2k pi, where k is an integer. Okay, and we have no singular. Okay. Then let us look at our next example now. Okay. This example, of course, we actually we need to know that of these, we need to work with a product rule. So f times g, so it's f prime g plus f g prime, and also chain rule, isn't it? Okay. Okay. So then let's see how we work it out this problem. So I have f prime of x is equal to the derivative of x to the power of 4/5 multiplied to x minus 4 to the square plus x to the power of 4/5. Take the derivative of x minus 4 to the square. Okay. This one will be 4/5 x to the power of negative 1/5. And this one right here, it will be 2 times x minus 4. And the inner function is x minus 4, the derivative is 1, so I'm done here. Then now, so now the trouble to this problem here is if we have just like what we have here, okay, if we have a times b equal to 0, then we will be able to find that a equal to 0 or b equal to 0. We could use this to solve the problem. Okay. However, right now we will have additions, okay, between these two terms right here. So we don't know, we cannot solve it this way. So basically what I need to do is I need to find a way to factor, okay, this out. Okay. So then go back to the idea about factoring them. Okay. So if I have x to the power 4 plus x squared, then in this case, usually we work with the calculate the smallest power. Okay. Then I have x, and then I have 4 minus 2 plus x, the power 2 minus 2, right? So therefore I have x squared, and then this is x squared plus 1. Okay, then we factor. Okay, so I'm going to use the same technique to actually to help us to factor this out. Okay, okay. Then now let's maybe let us rewrite this before we do the factoring then. Okay, so I have 4/5 x to the power of negative 1/5 x minus 4 to the square plus 2 times x 4/5 and x minus 4. Okay, this is what we have. Then first of all, maybe let us try to factor. Okay, so again, I would like to find what factor that should I do here. Okay, maybe let us take care of the fractions. So first, I would like to take out the 1/5. Okay. And then compare to the x term, then x to the power of negative 1/5 is smaller than x to, doesn't mean the power, right? Negative 1/5 is less than 4/5, then I take out x to the negative 1/5. Okay. And then how about this one right here? Okay, we have x minus 4. Then this one is a square, this is 1, so I'm using, again, work with the power of 1. Okay. Then now, to the numbers, if I take out 1/5, okay, to the first term, okay, to this whole thing now. Then if I take out 1/5, of course, I'm going to have 4 left. And then I take out the whole thing, x to the negative 1/5, okay? And I take out x minus 4. So I have x minus 4 left here. And then we add. So in this case, this is the number here is 2. And I take out 1/5, okay? So probably I will have 10, right? Again, just think of that. 2 divided by 1/5, meaning it's 2 times 5, okay? Or if you multiply 10 to 1/5, give you 2 back, right? And then now, how about this term right here? Okay, so I have x 4/5. And then look at this. If we take out 2, then what do? We subtract 2. So I'm going to subtract negative 1/5. Okay. And of course, in this case, okay, I take the x minus 4 out here. Okay, so this is what I have left here. Okay. And now, let's take care of it. Okay. So to this one, I have x minus 4. And then I have 5 here. I have x to the power of 1/5 here. Okay. Then let's see what do I have left inside the parenthesis. So here I will have 4x minus 16 plus 10, okay, x to the power of, you will see that here I have 4/5 plus 1/5, which is 1. Okay. And now I will have x minus 4 times 14x minus 16 divided by 5 fifth root of x then. Okay. And now let's see how I find the stationary. I would like to set f prime of x equal to 0. So if this is the case, that means I only need to worry about the numerator. So I have x minus 4 equal to 0 and 14x minus 16 equal to 0. Okay. Again, I don't care about the denominator because the denominator, when I set it equal to 0, then actually it's gone, right? Okay. Okay, so then now we will have x is equal to 4 and 14x equal to 16, and then x equal to 8/7. So then my stationary numbers, I have 2 of them, x equal to 4 and 8/7. Okay. And then now, how about if I want to find the singular? Okay, then I need to set f prime of x does not exceed. Okay, and then you will see that the only number that make the f prime does not exceed is when x equal to 0. So then my critical number. Okay. So I will have three of them. X is equal to 0, 8/7, and 4. Okay, those are the critical numbers to this problem. Okay, so then now this is actually one of the techniques that I would like you to remember. If you have the sum of, again, two terms or more than two terms, right? How do you actually again that's mean find the equations, okay? Find set it equal to 0 or does not exceed. What you need to do is you need to find a way to factor, okay, the expression that you have, okay, to make it become multiplications of two functions, okay? Then we will be able to solve from there then. Okay. Then now let us look at our next example is how do we actually find the absolute extremum now? Okay. So if you have a closed interval, remember based on the extreme value theorems. Okay. If we have a closed interval, then it's actually guaranteed that we will be able to find the absolute maximum and minimum. Okay. As long as we consider, again, the critical numbers. Okay, like this. And also the endpoints. Okay. Okay, so let's see how we actually work it out. It tells you that to find the absolute maximum and minimum values of a continuous function f on a closed interval, okay, it must be a closed interval. First, we would like to find the values of f at the critical numbers. So in this case, we would like to, again, finding f prime of c equal to 0 or f prime of c does not exceed. Just like the example that we have previously, right? And second, I would like to find the values of f at the endpoint. So we also need to work with the endpoint. And then to this one, probably we could use a table to actually to help us to do this. We could set up a table, okay? And then we would like to find the largest of the values from step 1 and 2. That means we look at the critical numbers and the endpoint. Okay. Is the absolute maximum value. The smallest of these values is the absolute minimum. Okay, so and now this is actually exactly what we want to do. First, we would like to find the domain of the functions. Second, we work with the critical numbers. And that means set the function equal to 0 or does not exceed. Set the derivative, right? Equal to 0 or does not exceed, then we are going to create a table to check the endpoint and the critical numbers as well. Okay. Okay. So then let's see this example. Okay. So to this example, first, the domain. Okay, we have a closed interval because the domain is between -1 and 2. Oh, that's good. Okay. Second, I would like to find the critical numbers now. Okay. Then, of course, I need to find my f prime of x. Okay. So we could use a chain rule. So I have 3 x squared minus 1 to the power of 2. And then we take the derivative of x squared minus 1. So then it will be 3 times x squared minus 1 to the square and then 2x. Okay. Then I will have 6x x squared minus 1 to the square. Okay. Or, okay, I would like to factor this out. So I have x minus 1 to the square and x plus 1 to the square. Okay. Then maybe I work with step 3. I would like to set f prime of x equal to 0. Maybe just continue working on step 2 then. So I have x equal to 0, x equal to 1, x equal to -1. Okay. And now we work with step 3 now. I would like to create a table that contain the endpoint, so which is -1 and 2. Okay. Okay. And of course, my critical numbers. So I have 0 and 1. Okay. Those are the critical number within this domain right here. Okay. Okay. Then now I would like to evaluate, right? So I have f of x equal to x squared minus 1 to the power 3. Okay. So this is what I need to do. So then now f of -1 is equal to -1 to the square minus 1. So we know that this one is equal to 0. F of 0, then I have 0 minus 1 to the power 3. So I have -1. F of 1, again, I have 1 square minus 1 to the power 3. This is 0. And then f of 2, I have 2 square minus 1 to the power 3. So then this is 4 minus 1 is 3. 3 to the power 3 is 27. Okay. So that means this is 0, -1, 0, and 27. And of course, to this one, we find out that this is my absolute minimum value. This is my absolute maximum value. Okay. Yeah, so this is exactly how we work on this type of problem now. Okay. Then now, let us work on this example now. Okay. Okay. So to this example, it didn't give me kind of like any domain of the functions. So probably we need to find the domain. Okay, we need to find the domain then. Second, I would like to use the calculus to find the exact maximum and minimum values. Okay, so in this case, probably they're looking for the absolute maximum and minimum. Okay. Okay, so then let's see how do we actually work it out this problem now. Okay. Okay, so first, if I want to find the domain of f, then maybe let us try to analyze, okay, the function then. Then now, we know that the derivative are not the derivative, but x is continuous everywhere. Okay, so the domain of x basically is all real number. Okay, then maybe this is the restriction to the domain of the function f. We have a square root of x minus x squared. Okay, so in this case, remember to the absolute that's mean to the square root functions. we don't want these to be negative, right? It could be zero, it could be positive, but it could not be negative. So therefore, in this case, what I would like to do is I would like to find, again, the domain of square root of x minus x squared. Okay, again, the domain of x is all real. Okay, so I don't need to worry about this. This is the only thing that I need to worry. Okay. So then now what I need to do is I could set x minus x squared is greater than or equal to 0. Okay. Just work with the nonlinear inequality, okay, to see how we actually solve this then. Okay, then now one way to do this is I would like to factor. Okay. Calculate back to the calculus, huh? Okay, so then in this case right here, we would like to see the 0, okay, of this, the left side of the inequality. So we find out that the 0 of x times 1 minus x, x equal to 0 or x equal to 1, okay. And now what I could do is we could create a side charge. Okay. For x times 1 minus x then, okay. So in this case, I would label out the 0 and 1. So we separate this into 3 intervals. Then we could plug it in a test point, and maybe we could use -1 to test, 0.5, and also maybe 10 to test it, okay. I just want to know that within those interval, okay, if the function is above the x-axis or below the x-axis then, okay. Okay, so in this case, when x equal to -1, okay, then this x times 1 minus x, okay, is positive or negative. So I will have negative times -1 minus -1, okay. So which is a, maybe let me write down. So I have negative 1 minus -1, okay. So this one, they give me negative, and then this give me positive. So meaning when x equal to -1, the output that I have is actually, it will be a negative then. Okay. And then how about when x equal to 0.5? Okay. Then again, 0.5, x is positive here. And then 1 minus 0.5 is also positive. So this interval is positive. Okay. And if x is 10, okay, then x is positive, and 1 minus 10 is negative. So this is negative. Okay. So that means in this case right here, the domain of this function is the x value must be in between 0 and 1. Okay. Okay, so then we are done with the first step, right? Okay, we found the domain. Then now we are going to work with the derivative. Okay, the critical numbers now. Okay. Okay, so again, I have f of x equal to x times x minus x squared raised to the power 1/2. Okay. So again, I will use a product rule and of course the chain rule to find this. So f prime of x is the derivative of x times x minus x squared to the 1/2 and add x times the derivative of x minus x squared to the 1/2 then. Okay. Plus x times 1/2 x minus x squared to the negative 1/2, and now I take the derivative of x minus x squared, which is 1 minus 2x then. Okay. And to this one, we will have 1/2 x times 1 minus 2x times x minus x squared to the negative 1/2. Okay. Then now, just like the problem, right, that we have this one right here, what I need to do is I need to factor something out. Okay. Okay. So then let's see, what do I need to do? Okay. First of all, maybe let us work with the 1/2. Okay. Second, we have this is x minus x squared. Okay. And of course, negative 1/2 is actually is probably the smallest power. Okay. Okay. So then let's see what we have here. Okay. Okay. So to this one here, then the first one, the coefficient is 1, but I take out 1/2, so I will have 2 left. Okay. And then this one will be x minus x squared raised to the power of negative 1/2. Oh, actually, it will be, my bad. Okay. It will be 1/2 minus negative 1/2, right? This is what we have. And then minus, okay. Oh, actually add, okay. Now we work with this term. So I take out 1/2, okay. And also, I also take out x minus x squared to the negative 1/2. So I will have x times 1 minus 2x, okay, left here. Okay. Then now, okay, let's simplify this. So I will have 2 times square root of x minus x squared. And then to the top, I will have 2 times x minus x squared. This 1/2 plus 1/2 is 1. And plus x minus 2x squared. Okay. 2x minus 2x squared plus x minus 2x squared. Then now I will have 3x minus 4x squared. Okay. Then, of course, I will be able to factor out x. So I have 3 minus 4x. Okay. So I would like to find the critical numbers. We would like to set f prime of x equal to 0 So I will have x equal to 0 and 3 minus 4x equal to 0. Okay. And also, we would like to have f prime of x does not exceed. Okay. Then in this case, of course, we will have square root of x minus x squared equal to 0. And as you know, I will have x minus x squared equal to 0 or x times 1 minus x. Okay. So again, x equal to 0 or x equal to 1. Okay. That means in this case, my critical number are x equal to 0, 3/4, and 1. Okay. And now I'm going to set up a table now. So to this table, I can contain the two endpoints, 0 and 1. And then I also contain the critical numbers. Okay. Then I'm going to work with f of x equal to x times square root of x minus x squared. Okay. Okay. Then of course, f of 0 equal to 0. And also f of 1. F of 1 is also equal to 0. Okay. So the only number that I need to concern is my critical numbers, 3/4 then. So I'm going to evaluate f of 3/4. And now let's try to simplify this. Okay. So this one will be 12 minus 9 is 3. And then this is 16. Then of course, I will have 3 with 3 over, this is 4, this is 4, so I have 16. Okay. Okay. And now we could make the conclusion that, okay, the absolute minimum value equal to 0, absolute maximum value equal to 3 with 3 over 16. Okay, so in this video, we work on a lot of problems. Okay, so and I think the most important technique I would like you to actually remember is if you have two terms, how do you factor and then make it become, okay, a multiplication of two functions. Okay. Okay, so thank you.